Hey everybody, I'm Dr. Gray. I will be your instructor this summer session for Chem 4351, Biochemistry 1. Let me tell you a little bit about myself after I talk to you about this course. So this course is the first of a two-part or a two-course sequence. In this course, we'll cover kind of your foundations and your fundamentals of biochemistry. The second of the two course sequence is commonly referred to as a metabolism course, in which case you'll learn a greater detail and in-depth understanding of things like glycolysis, which you've probably been introduced to in a handful of your other courses. But uh, in metabolism, you dive into it kind of on a molecular standpoint, not just like what's the point of the pathway. Um, so in this class, we will get into the structure, interactions, and functions of major biological molecules. We'll primarily be focusing on proteins, nucleic acids, carbohydrates, and lipids. We will emphasize evolution, thermodynamics, regulation, and the relationship between structure and function of molecules. And then this course is, for some of y'all, or for many of y'all, this is cross-referenced as Biology 4351. Now, the prerequisites for this course are at least a C or higher in Organic Chemistry 2, as well as in Cell Biology. Now, the Organic Chemistry 2, one of the biggest things and one of the most important things about that prerequisite is that you have to have a good understanding of functional groups and structure of functional groups and reactivities of those functional groups. For cell biology, we're going to use terminology like transcription and translation, almost second nature. So the better your foundation in biology, the better off you are at understanding and, taking things kind of in stride. Like I said, I am Dr. Joel Gray. You can contact me at this point in time. My email address that you can use is jwgray9@gmail.com. Though this is an asynchronous course, I want to make time available for y'all. Should you have any questions, I'll have office hours Tuesdays 8 to 9, Wednesday 1 to 2, and Thursday 12 to 1. So if ever you want to drop by, or if you want to, shoot me an email and, you'd like something answered within that window, those are the windows of time that are going to be best. So this is a challenging class, but this is absolutely a class that you can succeed in. And there's a couple of suggestions that I have for how to make sure that you are successful. One, whenever there's an assigned reading, make sure that you do that. Take notes on it. What are the high points of that section? What were new pieces of terminology that were introduced? And then after that, like, what was the point of what you read? I know personally that's something that I always struggled with as a student, is I would read, whether it was 2 pages or 12 pages, I'd read a section of my textbook and then I'd look back and I'd be like, what did I read and why did I read that? Try to answer that question, like, what are you reading and why are you reading it, with every kind of passing sentence in every section. Um, Next up is what I highly recommend. I think this is a very important thing for you to do is try to put yourself in your instructor's position. Try to write your own exam and quiz questions. Now, the more challenging you make those, think that the more time that you spend trying to write your own exam questions, the better prepared you're going to be for the exam questions that I write and that you see. Um, and I think that everyone kind of has an internal barometer of what makes an exam question difficult and what makes one easy. In addition to that, I think that when you get into the habit and you do this sort of practice, you ultimately come up with kind of your own algorithm of sorts. And then you realize that, oh, well, everyone's coming up with their own sort of algorithm. Every exam follows some sort of pattern. So, if you think about a multiple choice question, one of those answers is going to be correct. Excuse me. So it's entirely possible that the, if it was a numeric or quantifiable answer, then the correct answer might be the result of adding two values. And then immediately, well, the incorrect value might be, or the incorrect result might come from subtracting two values. So you kind of have like, here's the correct and here's the opposite. Um, and then you just kind of build in, excuse me, excuse me, um, some potential, like, here's where something went wrong whenever it comes to writing those incorrect answer options. Um, Next up is practice concepts, practice understanding concepts until you're you're firm or you're solid in them. I think that that's probably one of the most powerful things that you can do is basically continue giving yourself example problems and say, do I know how to do this? And be honest with yourself. Um, no, I don't know how to do this, but I really want to be done with it. Okay, well, those are two separate things. Next up is don't get behind. Um, this is an asynchronous course, so I think that although we don't have a set time of the day that we'll be meeting to go over this content, I think that it might be worth your while to say, okay, well, I'm going to look at it every day, at least from 10 till 10:30 in the morning. And, give yourself that time frame so then you know that you did some of the work, you watched part of a video, and you're going to set yourself up so that you can be consistent and pace yourself. Um, this is a summer course, so it's going to go very rapidly. So it's going to be difficult to recover from a bad exam. It is possible, however, and if you get two bad exam scores, despite the fact that we have four, it will be very difficult to come back from that. So just please keep all that in mind. And I always like to look at Bloom's taxonomy because this is, I think, a very powerful way to think and understand things and a very powerful way to visualize your different courses that you've taken throughout your collegiate career. So if you look at Bloom's taxonomy, we have a range from 1 to 6, and it's these simple understandings of your foundation or your factual knowledge is the first thing that you do. That's at the bottom. You remember and recall factual information. Now, some of that is like, uh, and then you have comprehension, demonstrate understanding of ideas and concepts. Third would be application of information, so apply comprehension, so apply that you understand it, the information. Then fourth would be analysis or analyze the information, break down concepts into individual parts, so you are critical of it almost. Um, Synthesis is fifth, where you transform and combine ideas to create something new. And then at the top of the pyramid is number 6, evaluation. Think critically about and defend a position. So then you have an opinion about something. So that's at the top. Now, I always like to think about this as like your freshman, sophomore years of college were largely the first three. So, or the first three, sometimes into the fourth, where you're accumulating this large body of factual information. Um, you need to demonstrate that you understand it. Then you need to apply it to unfamiliar situations. And then sometimes you're breaking it down into concepts, for instance, or breaking down those concepts into parts. For instance, you start with like your first biology class. That was a very, very broad class. You talked about basically classification of every different organism. You kind of narrowed your scope. You worked and you narrowed, narrowed, and narrowed. And then as you continued after that level, you got into like a genetics course. Did you talk about genetics at all in your first biology course? It was alluded to, it was touched on, but you didn't go deep into it really. But then when you get a genetics course, then you definitely go deep into that information and you go deep into that topic. Now, with that, we're now in a biochemistry course where we're the way that I always like to think about this is that um, you're transforming and combining ideas and you're creating something new. I always think about biochemistry as perfectly encapsulating that idea because what you've done is or what this field consists of is the field of chemistry as well as the field of biology. You can transform ideas from both of those, apply ideas from both of those fields, and make something new, and that would be your biochemistry course. So as an example of differences in Bloom's level, so if you look at this right here, name each of the functional groups on the side chains of the amino acids cysteine and serine. So here I've got a pair of amino acids. Now these are structures that you may have a little bit of familiar with. You maybe have seen them before, or you maybe have been exposed to them in kind of your everyday life. And on the left-hand side, you have the amino acid cysteine. On the right-hand side, you have the amino acid serine. Now, your base level there would be to know what those structures are. Excuse me. But as you can see here, I'm kind of proposing that you name each of the functional groups. So then you'd be able to say, okay, well, this right here is a carboxylic acid. This is an amide. Being able to decipher those, identify those, and say this is a thiol. Well, then you're analyzing this molecule. You are kind of digging deeper into this molecule. So that's something that's higher up on Bloom's taxonomy, or higher up in the Bloom's pyramid. Excuse me. Now, that seems like something that well, that is something that you're bringing prerequisite or background knowledge from your previous classes into this with. Now, next up, however, is let's look at an example, or let's look at a scenario. A protein, chymotrypsin, has a reactive cysteine in the active site where its side chain acts as a nucleophile to start catalysis. Predict the changes that we would expect, or that would be expected if the cysteine were replaced with a serine. Okay, so now you're building on knowing the difference in those functional groups. And then you're taking that and you're saying, well, what do these different groups do? So you're going deeper into this. And then finally, you're you're reflecting and saying, what do I think would be the difference? And then finally what you're doing is you're kind of drawing a theory. You're taking a position. You're going to say, oh, well, I think that this oxygen, this hydroxyl group here, because that's the only difference between a serine and a serine, or a serine and a cysteine. I think that this hydroxyl group is going to give me or it's slightly more negative, or more electronegative. So I would expect more um, hydrogen bonding to take place between this and anything else because this can hydrogen bond. And I think that the hydrogen bonding that this residue can participate in would ultimately deteriorate the activity of this protein, chymotrypsin. You're taking a position, you're proposing a theory basically. And that's kind of what is most desired from any class where period, any class period. You learn the foundational information, you process it, You then think about a particular situation and what you've processed and packaged, and now you're going to rearrange it and say, all right, here's what I think is going to happen. Now, things for this class that I think are very valuable for you to be thoughtful of and think back on. Um, there is quite a bit of prerequisite knowledge that you need. Draw the structures and name of each of the organic functional groups. Now, I'll tell you that there's a handful of functional groups that we'll see more so than others. For instance, an amide and a carboxylic acid, we're going to see those almost more than 2 to 3 times as much as anything else. But we see tons of other functional groups, and the more that you know about those functional groups, the better off that you are. So to address that, what I would do is I would just go to Google and I would type in organic functional groups. And based on that result, based on a Google image search, you're going to get probably 10 to 15 most common organic functional groups. Um, get familiar with those, and then think about where the electrons are on those different individual functional groups. Number two, write the reactions for various functional groups, including bonds formed by condensation and broken by hydrolysis. That's kind of a Bloom's exercise unto itself because you're recalling all these functional groups, but then you're saying, what do those functional groups do? It's the next level sort of thing. Number three, write a balanced chemical reaction and determine the equilibrium constant. Products over reactants. How do you account for coefficients or anything like that when you're writing a chemical reaction? Well, you definitely need to. So given what the products are and the coefficients are, you've got the concentration of your products raised to whatever coefficient they have, divided by the concentration of your reactants raised to whatever coefficient they are at. Now, fourth, be able to calculate the concentration of a solution or solute in molarity. Um, Another little detail to that is more times than not when we're talking about a molecule in a biological system, we're talking about it in the on the level of like millimolar or nanomolar. We're talking about very, very low concentrations. So this isn't really like a Gen Chem 1 lab or class where you're dealing with a 5 molar solution of something. We deal with things on a much smaller scale. I think that it's helpful to think about um, sugar and your blood glucose level. The typical blood glucose concentration, or like a healthy range for your blood glucose concentration, is, I believe it's about 5 millimolar. Um, you don't want it to go considerably higher than that or lower than that. Yeah, it's right around 5 millimolar. I was Googling it on another tab here. Um, Try to think about like when we make a solution or when we talk about solutions, we should be thinking about it on that kind of magnitude. These are all topics that you should be familiar with because you've seen them numerous times. In addition to that, take a moment to reflect on calculating the pH of a solution. Uh, so if you think like a 0.4 molar HCl solution, well, a zero point 0.4 molar HCl solution, that's going to be zero point 0.4 molar hydrogen ions because HCl is a strong acid that will fully dissociate. So then you'll do negative log of zero point 0.4, and that's going to get your pH. So this seems intimidating. It's always kind of intimidating whenever an instructor says, make sure that you know how to do this. I'm not going to be going over these things. Um, and yeah, it is. There's no really trick or anything about that. Um, but make sure, so sorry, we will be covering some of these things, but it's probably going to happen pretty quickly. So whenever I do a question about what's the pH of this solution, it might happen pretty fast and it might be like, oh no. And so, I'll record all the lectures so that you have those to kind of scrub through and go back on. But if you have a question or like a follow-up question about how did I get this, or I did this step too quickly, don't hesitate to ask either in office hours or by email. All right, everyone, have a good one.